telling you in advance what I'm going to tell you. And not like journalists who will leave it for later. You guys read it first, and then I will tell you what I mean. No, it's all out in the open. Besides, there is a recording. So if you ever want to listen, you can. Okay? So I'm allowing everybody to talk here. And I do welcome talking, and I also welcome chat. So you can type anything you want, in particular where you are dialing in or what specific questions you have. Meanwhile, we can start. Here we are. That's the plan for today. Today is February 9. Let's verify. Yes, indeed, February 9. And we'll be talking about a couple theoretical things and a couple practical things. The theoretical thing will be Google showing off their specific use of AI, which is very important for me, by the way, because I'm going to teach, and I probably mentioned that before, next week I'm teaching at a place where LLMs are verboten, which means that like people are killing themselves, but the haunches of the corporation are not killing themselves, they're killing the employees. And the statistics, as I recently read, is that 25% of companies forbid the use of GPT. Well, truth is that people do use it and they have to be careful. There are rules on what to do, what not to do. But that is because ChatGPT is the king and all other LLM models are also good, and they all allow. That's the first in my mind, the first use of AI where it is packaged for you to use. You can talk to ChatGPT, as you very well know. That's different from all kinds of fashion recognition, CNN, not of course the studio, not the TV station, but convolutional neural networks. So all of that is very good to show off, but they're not practical. Very good if you're Facebook to recognize faces, but not for us, just to run. So that is an example that is good. Good about in the sense that it is useful. Okay, seems that it wants to download. Okay, let me download. And it is a useful application. It is specific. Not much you can do about it. It's not generic. It's not chat. You cannot ask questions, but it does something specific. So let's go there. It's right here. And that gives me pleasure because I can say, guys, I told you this, what you're allowed to do, neural networks, is nothing compared to ChatGPT. And what you're not allowed to do, you're not allowed to do. So here's an example where you are allowed to do, and you have a chance to use it in the sense that you can build something like that. Well, the truth is that it will take you PhD and beyond PhD level, but that I'm not going to tell. So here are the slides. I prepared some slides for you to look at. And I started. If that sounds somewhat familiar, well, it is. I did talk about this, but I continued. And that is what I will show you today. So let us go and do a slideshow right here. So first of all, I'm resuming the show, and second of all, I'm clicking on slideshow, and it doesn't want to do the show. Why that? From the beginning. Okay, that worked. So Google comes back in the sense that you'll see an amazing thing. Google, the world leader in AI, is struggling and cannot get back. So there is news every time, and it's a flop every time. Just yesterday, you probably heard that Bard is no more, and in fact, it's forbidden to even mention that Bard. But there is a new model, and I welcome anyone who wants to talk about that. But that one was printed maybe 2-3 days ago. And the background story for that comes from the book Maniac. The book is about von Neumann. But the last chapter of that book is about Go. And so Labatut, that is a last name, he's Benjamin, but they pronounce it Benjamin because he is from Argentina. So he gives us the story of Go, of how it was clouded in legend, and how today there is a world champion, this and all. And then he creates such an interesting story about how AI won that you can read it non-stop. It's just like a detective story. So this very impudent gentleman, Lee Sedol, used to say things like, I have no confidence in this game, in the sense in losing. That's what I meant. Well, okay. So Kim comes his nemesis. And nemesis is Demis Hassabis, an interesting person from North London. I had to look up why is it important that he's from North London. I couldn't find really a great reason, but London has 4 parts, obviously, north, south. And that's one of the posh areas, even though his parents were not rich. But his story is that he was a chess champion, and then he abandoned this world career of chess, but he wanted to build either a chess player who would build all humans, or a game player who would beat all humans. Meanwhile, he was accepted at Cambridge, but couldn't go there because the rule is you're under 15, we don't let you. So he waited for a year. Meanwhile, that year he used with big profit and created a game, multi-million-dollar game, and paid for his education. So he created a whole company. Company was called DeepMind. Now we think DeepMind is part of Google, and it is, but he started that company and sold it for like 600 million to Google. So there's a story how computers get better and better. What we are interested in is really not the exciting part, but exactly how that was done. The system is called Alpha Geometry. Alpha reminds us of previous system, AlphaGo. And the idea is that you need something very, very smart. The smart approach that they used is this. You need to train your computer to solve Olympiad geometry problem. So I remind you that they did train the computer to play Go, and initially it first looked through 100,000 or millions of books and games, and then in the next version learned everything by itself. It did not use any theory of Go. It just played against itself until it became better than everybody. So that idea continued, and they published this article. What does it say? January 17, I think. It is doing it like that. They draw, let's say, 100 million pictures. And about those pictures, they make statements, geometry statements. Then they prove these statements. All of that is done by machine without human involvement. And then they can solve any kind of a problem. In other words, sort of you train yourself on just geometry, and then you try to solve Olympiad problems. Now, if you're a mathematician, you perhaps work parts of such Olympiads, and perhaps you were like region champion or maybe a region team and then high and high, high. So that one, I just explained that. That one came to the level of very, very close to the best of the human champions. Very close by obviously self-training. Out of 30 Olympiad problems, then it solves 25, and it never saw them before. It trained on something else, on its own artificial created problems and proofs. And I think I have somewhere I have a picture. There, that's what I wanted to show you. So this is our alpha geometry, and this is our gold medalists. And as you can see, it's very, very close. So by the way, it's not inconceivable that it will be better than humans now, because the usually quoted problem with AI is that, oh, it learns from humans. And if it learns from humans, it can never beat them. So there you are. That is the second system that doesn't learn from humans, but instead it learns on its own, and therefore it has a chance of beating humans. AlphaGo did beat humans, and it only suffered from hallucinations. So if hallucinations is something that bothers you in ChatGPT, well, that is also a problem with that, but that's what it was, probably fixed by now. And out of 5 games, it won. The AlphaGo won the first 2, then lost the third one due to hallucinations, but easily won the remaining ones. Okay, now I have some chat. If it learns from humans and can never beat them, that's right. But now that it doesn't learn from humans, that's what Angie says, that it did beat humans, the AlphaGo did. Okay, Angie asks how. Reinforcement learning, proximity policy optimization. So with Go, it was playing the games against itself. It's not really a reinforcement learning. If only you can say that if it won, then it gets a candy as a reward, but that was not exactly it. So yes, reinforcement learning and proximity policy optimization are nice terms, and they are used, but here they are inventing new and new technologies. So that's one. And another one, I see also somebody says something here in chat. Thank you for the URL. Somehow I cannot copy and paste. Is there any way? Yes, I can give you a bit.ly real quick. And in fact, I do need a bit.ly here because it's nice. So let's just go to bit.ly. Okay, the link that I'm giving you is this, but I will translate it to a very nice combination of letters. I think it's picking up the title. Well, it doesn't get it, so AI webinar. And now create, please, a link. Well, where is the link creation? Enter. Yes, enter. That is the link creation. And copy. So what I will do is this. First of all, that is the bit.ly link. So it will be fair to put it right at the top. And then you can always use it. And also it's nice to put it in our chat. Okay, and Lorden, that's the link. So please tell us if it doesn't work, because I would assume that it does work. So, okay, great. Thank you very much. Now, I also see some question and answers. Oh, interesting. Is there a research paper? Of course, there is a research paper. Yes, it's Alpha Geometry by Google. By the way, all the papers, all the things are found right here. So I already gave you the bit.ly. With that bit.ly, you can open that. With that, you can open the drive, which is also shared. And that's where I store all the things that are needed, all kinds of slides and everything. That's where it is. That's how you can find it. So let's go back a little bit. Maybe some people are new, maybe they're first time here. We usually talk about some theory. That's when somebody else does something. And then we talk about practice. That's when I do something. Not that I do anything grandiose, but at least I'm trying to use and replicate what other people do. That will come here, and that is the giveaway of what we're going to talk about. So first we talked about alpha geometry, and I showed that to you because I personally am interested. Is there any use for neural networks? Of course, yes, there is some use for neural networks, but is that a just example that you show off? No, that there is a real approach. It can best humans in a specific area applications. ChatGPT is the best in the more or less general. I think there's a disagreement. Should we call it a general AI or not? But it talks to you at least and talks about everything. And sometimes it's very funny because yesterday we have integrated this ChatGPT into an application for lawyers right here. APP. That's the application for lawyers. And what we do is store legal documents, right? And store legal documents, sometimes convert them to text, OCR, but then you can ask right here. You go to ChatGPT and ask, tell me who are the suspects. Hey, let's see. Yesterday something crashed and didn't work, and we had to cancel the demo. So that's more lively. That's more human, but it does work today. And it tells you here are the suspects. And by the way, that is the link on which the ChatGPT is basing its opinion. So it's very nice. It's just perfect for lawyers in the sense that it's not too specific. It's the jurors should be able to understand what's going on, kind of thing. When I'm working on the medical system, that is a totally different story. But this is just blah blah, as my wife puts it, and ChatGPT excels at that. So what I wanted to tell you is a fun story about how we were testing it, but the people recorded in these audios are not using the perfectly good language, and they're not doing the perfectly legal things. So when we were asking ChatGPT, where is this dick in this case mentioned, and it knew, and not only it knew, it was guessing the intent. It was not pejorative. It was very positive. Okay, that is a little diversion, saying that it does hallucinate. But now we're going back. And the next thing is building applications. So let me look in the questions and answers. That's an interesting link that you're giving us. So why don't I open it? Right, I hope that link goes through. And that is about will boost AI adoption. Very nice. And I would say will boost AI adoption in a very special way by giving you ideas how to develop things that are not ChatGPT. Thank you. Thank you for that link. So I'm going to switch gears and look at that. And that is a new course which we started looking at. But yesterday I really had to do it. And the reason I had to do it is because my system wasn't working. Now that I'm talking about medical system, and it was the lawyer would, the doctor would ask very specific questions about special, I didn't understand anything about what he asked, but it was about specific drugs or specific prescription drugs. And here's what I found. That when you're talking about legal things and suspects and all of that, that's general conversation. So you understand that, and ChatGPT does. But when it is about the doctors, we have two problems. First of all, we want a good source of information. ChatGPT will talk about anything, and who knows if he's right or wrong, right? Maybe hallucination. I think I told the story how it shamelessly lies about things. All right. So instead, in this system that I'm working on, not that one, but another one, medical, we use manuals. We use specific doctor manuals approved by government authorities or governing authorities. So the source of information is good. But now we have to look for answers in multiple sources, hundreds. So for that, I implemented parallel search. I'm asking multiple data sources at once. And number one, it's not as fast as you would like, but at least it's more or less, okay? And still, it doesn't get the right answers. And why is that? Because if you have a big document and a certain term is mentioned in this document only once, then the famous RAG model doesn't work. Because RAG, built on vector databases, finds something that is similar by meaning. And similar by meaning includes so many words and it gets them. But if only one word matches your interest, then it just misses them. Well, it turns out that in the latest course by Andrew Ng, taught by Tim Tully, who is an advocate in this, and that is not just vector databases, he means Pinecone. So there is an approach right here where he talks. I'll start, but you will not hear. Okay, hybrid search, that's the key. Wonder if I can call it. Okay, that's the key, hybrid search. And what he means is that he's going to build his search on a combination of by meaning and by keyword. Now, I thought of implementing it myself by first looking into regular search, that's by keyword, and then by meaning, but that's better approach. Because when you look for things by keyword, you get too much garbage, and then you're lost. How are you going to do meaning in this heap of garbage? So you need something smarter, and it turns out that's exactly it. That appeared, it was published like a week and 2 days ago, I think. So right on time. And what I did yesterday for you guys is really put it on my machine. I think I could even run it here. And it does all the imports, but if you just download that notebook and do the imports yourself, of course it will crash. So yesterday I went through and I did it correctly. So that's what you do. You download that machine, the notebook. The way to download is this. say download as and download the notebook. But the downloaded notebook will not work. Then what you do is File, Open. When you do File Open, you will see additional files that are there. That are kind of hiding there, but with the File Open, you can get them. And that's where you get additional utilities, plus the data. So with that, it worked for me somehow without the data. I don't understand. With that, I'm going to my labs, opening AI, then switching my content environment to Open AI, something I call Open AI. And then I start GPT-Lab. So I get the same notebook to run for me, and I will do this. I will clean it because we don't want just to read it. We want to run it and understand it, and that's promising. Now you can search for rare gems in the web search, and also you can search for by meaning. Now I will clear, restart and clear. And I see that there is some question and answers going on. So recording, yes, Asma, the recording will be available and you will get it. You don't have to worry about anything. It will come as an email a day or two after, but it will come to you. The dataset, import datasets. Yes, you already saw that, but I don't understand. I didn't bring the data consciously. Somehow it seems to get it. So what we start is, I'll tell you, but what's important is that later on, the general scheme of things, we are going to look through the fashion items. So we are imagining ourselves some kind of a store selling items, and you would think there is image recognition going in, right? You would think that when we ask for men's jeans, then we're looking for pictures, but please don't think so. We are looking for fashion items designated by words, but we're looking for specific words. We assume there are thousands upon thousands entries, and so we do need all the power of search that we can get. So let us start. Let us ignore all the warnings, good practice for the demo, but not for real life. Then we will import quite a few unusual libraries. We import regular libraries, but also Pinecone text and DLA utils. That's all already taken care of, so that works. And we get the key, Pinecone key. In my case, I think I do have the Pinecone key because it works also somehow. So now we need to set up Pinecone. Now, that whole notebook won't be a kindergarten exercise. I think they don't do it at kindergartens. There are some very brilliant youngsters, but that's at least on the level of very brilliant first grade of elementary school, I would think, but really it's a PhD level. So a little bit above the regular level, but first of all, it finds, do I have a CUDA, which is a way to use a GPU if it is present on my computer. My computer doesn't have it, and it detects that. It says, no worry, we can still do it. So we're loading this fashion. Yeah, and it was somehow cached somewhere. I don't understand how that worked, but then that whole notebook is not easy. I have to still work on it a lot to understand and use it, because imagine what I need it. right? I need to look for a combined, as they call it, or hybrid search in the drug by name and in the meaning of the words. So, well, I have to replicate exactly that. So maybe it will take more work and maybe I'll show the results, maybe integrated with the drug search next week. But right now, okay, so we're getting those items, fashion items, and they are descriptions, not pictures, even though the pictures are really there, and we will use the pictures just for the show. You see, there is a picture, but that's only to attract your attention. But really, it's that what we are going to search for, and how many are there. I don't remember how to. I can do this metadata size probably, but let's try it. Metadata size, and then I have to say print. What they do is simplify things. If you mention something as the last thing in Python cell, it is printed, but then it's not the last one and it's not printed. So I do the print, and what do they do? Oh, how could that be? Maybe I missed. Okay, let's restart. That should work. At least that much should work. My rule is demos never work. So if something doesn't work, that is normal. That is to be expected. So we find out that I don't have CUDA. We find that's where our data is. And now it says you don't have it. But it worked yesterday. What can I say? We'll ignore that. And maybe it didn't like my size. Okay, so now that's the key. We are creating a sparse vector. What is a sparse vector? This is regular search. Regular search is done with just a few numbers. It's done with the frequency of the term, the frequency of the term in general. That is the familiar TF-IDF, term frequency inverse document frequency. And that is just a couple numbers. That's why it's called sparse vector. But they're using something smarter than just TF-IDF. They use a certain library that implements that. Well, the most important thing is that we do check by keywords. And then we go on. And now we created by meaning. We're going to do dense vectors. That's just a nice term for vectors that are reflecting meaning. And how many of them, how many of fashion items? 44,000. Well, that's a lot. It's very hard for ChatGPT to just make sense out of that. But together with the search, you can do it. Okay, so I'm just showing you that it's not easy right here without much explanation. And I'm also showing that it's going to do quite a lot num crunching. The end result is that we are going to get what we're looking for. We're looking for dark blue French collection jeans for men. If you just do simple-minded search, you'll get too much garbage. But if you do smart search, if you do search by meaning, it doesn't even find it. So a combination of those things does it. And that is as far as I wanted to go. You can hear my computer working very hard here on the background. That's all the demo I intended to do. So let me do this. First of all, look at who said what, and also allow everybody to speak. Everybody who wants to can say something. And now that I allowed you guys to speak, I will stop sharing the screen and also stop talking. What are the specs? My specs, I don't know where is that, but I remember it's 6 CPU. It's a reasonable machine. No, that's not cloud, that's local. And I don't use GPU. My logic was that I am not great at hardware, and if I need GPU, well, that's in the cloud. But thank you for asking all these questions. So what I'm doing is stopping the share and stopping my mic.
Oh, thank you for sharing that. That was awesome. I was the one asking about the specs because for running these types of models, by the way, your model combines a search between an image vector, right, and a text-based vector all in one data frame, right? So
yes, except that this image is a little bit misleading. It's not really looking through images. It has an image attached to each input vector, but the vector itself is words.
Oh, okay, interesting. Just a description of the image, basically.
Well, just the pixels of the image, just to make it look nice.
Oh, okay, awesome. So when you tested it, how well did it do with being able to find meaningful query results? Like, for example, the dark blue.
Yes, that's a good question. When I tested it, I essentially tested what the who is it, Pinecone prepared. So of course it worked. They said, oh, it will look a little bit better when we use it, and it did. But the real test will come, for example, when I'm implementing this for medical search. That will not be something that they control, and if I'm able to even implement it their way, I will have a good, honest answer. Is that what you wanted to know?
Because it's more risky to get the search result wrong in the medical domain.
Yes, well, in my case, they ask about specific prescription drugs, and it's not even finding it. Now the doctors say, oh, but it's here. Well, of course, you read it. Or I search it, and we'll come to that. How I can both search and do ChatGPT. But that I can do in 2 separate tabs. What we want in 1 tab. That may be a little bit unclear, and I will show you.
Okay, so why use a generative pre-trained model for a search, and it's in lieu of a search algorithm, a traditional search algorithm that has a better time efficiency, for example?
It does. It's faster. It's very precise. We're talking about regular search, right? But it brings too much garbage. For example, if I use all these terms, okay, going back to the screen. The terms that they use: dark blue, French connection, jeans for men. So, do you put an and between these terms, or do you put an or? Depends upon where you are. If you're on Google, it has a hidden way to do something, so it's not very indicative. But if you run it through some open source search engine like Lucene or Solr, then it assumes, I believe, or. Now, to be very precise, you tell it. You say combine it with an or. And if you do it, you'll find too much. So then you say, no, I want an and between them. If you say dark and blue in French, well, what if one of those terms is not found and you don't know which one is not found? That's where it gets complicated, because regular search is only capable to do very strict things, and ChatGPT understands what you mean.
Okay, I forgot, because it's been a while since I've revisited data structures,
Mhm.
the most efficient search algorithm. But I believe that that the multi-head attention, the attention is all says, has a table in that paper about the time efficiency of the multi-head attention mechanism being like O of 1 or something. So is that why this is better than the traditional searches too, even without the
That's, yes, you're right. You remember and know all of that, but that's only step number one, because you will be able to find the suspects. You will be able to find the documents which might have the answer. And then comes ChatGPT, which is another $1 billion invested in training on top of that.
Oh, I see.
And that lab combines the advantages of both. You still use the first step as a search, but on and on. It's a bit more complex. I didn't want to go too far. All right, so I have to apologize that I will continue, but we can maybe email, we can figure out how to talk. Or you ask, describe that next time, and I'll put it in our plan to talk next time. Good. So now that I'm sharing the screen and I got some reaction, I'm looking in the QA. Look there, and I'm looking in our webinar here. And I showed you this. So we looked at alpha geometry as a promise for people who want to do good work with NLL neural networks, that they have some hope. I showed you the latest and greatest. In fact, I have a long list of what you could learn. It's found right here, called Learning Path. That's also open. And when I see the new great course, I try to run. I put it into my own repository, and I explain what the course is about. So sometimes, and that's the dirty secret of a corporate trainer, I repackage it and then I teach it for money, even though it comes to me for free. But that's a lot to learn, money or no money. It's a lot of things to learn, and it's right here. If you're interested, start at the beginning. Now, okay, I'm going back here, and here what I'm doing is this. I have an open source engine which does very similar things. So I will just open it rather than talk about this. So that is in the cloud, and I just announced that it's there in the cloud. And here I need to go to my cloud. And find one of those machines that are running. And people started asking for that. Here, one of the people pressed. So that's a read version, what you see, and therefore it's okay to read his version. Besides, it's not his. It has a regular enron. So what you do is open it like that. And I load cases. In this case, I loaded only one case. I took an Enron mailbox. If you have not heard, anybody who has not heard Enron mail story, is that It was a public company, and therefore all the litigation went in the open, and that's the best source of data for the last 20 years. So I took one mailbox, I loaded it here, and if I want to see what's in it, I just put a star. And that is 2339 documents, regular e-discovery or more or less regular discovery. Oh, he did put some tags here. I see that. But if I want to look for something specific, then I can say it's a Bailey mailbox. Show me Bailey. And these are all of her mailboxes. That's Susan Bailey S, right? So each document is here, and that is keyword search. So if we go here, then that is the link that helps us with the language of the search right here. If you want to look for John, you can do it. But if you want to see who is the custodian, then you can say first keyword, then column, and then custodian. So, for example, I can do creation date because I know that that's how they code creation dates with creation dash date, and the case is important, and then give it a link or really the range. That explains. I think we should try it here. Doing the search, and we're trying that, and it didn't find it, but at least it understood what I'm looking for. Let's try something. If we start maybe just to make sure we cover everything, and end kind of today. No, still doesn't work. Okay, demos never work. I told you so. But that's how you just search, but that's how you talk. So, the person or Bailey. Now, couldn't not know, but that is a link to what it tried to search, and Susan Bailey was there. So maybe I didn't ask, it doesn't know about her, but is person called Bailey. Yes, that's a typical lawyer for you, right? You ask him, do you know the time? And he says yes, and doesn't continue. So yes, it knows a person called Bailey, and that's how it knows. So that's a combination of search and AI. And that is for somebody who is interested in this, because that's for e-discovery legal. One interesting thing that I added not for e-discovery is this: ask all cases. So that's the latest thing that I added. Let's say you have 40, 50 cases, and you want to find where a judge was prejudiced or something that requires investigation of all of them. So you can click here, and it will be looking for all of them in parallel. Right now, it doesn't work as fast as I would expect, but in parallel, it will look for all of them and goes across the cases. That is the latest and greatest things that I'm personally working, and I often fall and things don't work as they should, but it's a lot of fun. That's what I wanted to show in the practical area. So if we go here, right, that's what I wanted to show you is the latest freed AI, and the goal here, by the way, aren't to implement these. For example, can you find PII, can you find personally identifiable information? Right now it cannot. It will tell, I don't know. But in the future, that will be really useful because talking to ChatGPT, well, that's fun. And that's not always perfect. It might be very good for criminal. And that's what the lawyers who work with the Caseify say, that instead of reading all the long conversations, they just ask ChatGPT and amaze the judge. How did you know? But for civil, they are more interested in specific things. For example, can you find documents that have any relationship to this lawsuit? And here you load it with what is the lawsuit about, and I will tell you if the document is related or not. That's future. I said there will be something in the future, the plans, that's this, and that's the current demo. So right now I got a couple people interested in the read-only. Can I just play with it like this? And yes, and in the future, of course, they immediately ask, well, can I load my data? And can you white label it so that they put my name on that? That is a very natural thing to ask. All right, now what I will do is this. Look at the question and answers. And then no new questions. And then stop sharing and invite you all to ask or say something.
Yes, so I wanted to say that this bot seems to be fine-tuned on legalese, like you were saying.
Definitely so, yeah, because that is for them, right?
So yeah, it wasn't able to recognize the first question when you had to rephrase it. And
yes, and maybe there was something else, but that same technology. Okay, back to share.
And that's totally fine because that's normal. That's even how humans are. But the thing about this is that shouldn't it, instead of saying, I don't know, say, may you provide more clarifying information or something like that? Like
yes, you know, what I do is I send the question to ChatGPT with all the additional information and just broadcast its answer. Don't do anything with it. But a proper system should customize the answers. It should do something. By the way to do it is to use ChatGPT again, because it can answer anything. For example, if you ask, was there a murder? Even if there was a murder, it is not going to say yes, because was it a murder or accidental death, right? So it's not going to say things that may be argued against. So you don't know what it will answer. And every time you do your questioning, it answers in a different way. How do you know if that's right or wrong? Well, you ask it, in this answer, did you provide the answer? Kind of thing. So it's more complex again than meets the eye. And that is only the beginning. And more is coming your way if you implement such things, and my way if I implement them.
That's interesting. So because ChatGPT employs constitutional AI for detoxifying or changing certain responses to be more human-like and appropriate.
Yes, right. Still don't say this or don't do this. Yes. By the way, talking about constitutional AI. In this Caseify, we add what's called the case law. So I go to AI in any of the cases. Right now, you can add either gas chromatography knowledge or California instruction for criminal cases. But there's a whole plethora of different things you could add. So at a certain point, it won't be that simple. We just got a new request, Arizona statutes. Can you add that? Okay, we can, but we begin to think, how do we add the additional knowledge? And when you tell it, Just base yourself on these instructions. Don't use your knowledge of the world. It still uses the knowledge of the world. So to add more excitement,
Oh, I see. It could be fine-tuned for a specific use case.
fine-tuned, and you're trying to cajole it to do the right thing. It doesn't always do it.
So would you ever build your own custom, like for example, LangChain or React model?
I personally do those things. You see exactly what I'm doing.
Well, yes, I've seen
It's applications.
you've done that many times.
Well,
Instead of like
well,
sending it to a chat GPT, you like maybe like would there be other options or is it too is it
Well,
not?
one thing I will not do is build a competitor to ChatGPT or build another big model because it at least costs like $500 million to just train it. So I'm a simple-minded user of that technology, and that's the use of that technology. Well, tell me about Paris. These are the usual questions that they ask. Now, I clicked a lot, clicked on gas chromatography, has nothing to do with it on calculum. That's why it will be longer to think, but Lewis charged for the minute, so if it's trained to spend a few minutes more, you will understand why it's doing that. And it also gives us an error. That's kind of embarrassing, but very good that happened to us. We'll keep working on our applications. So if that was your question, what am I personally doing? That's what I'm doing.
No, this is great. I've seen several of your presentations already. It's already robust. I was just really exploring why, because I've seen that too on Streamlit.io. A lot of the projects use OpenAI's Turbo 3.5 model instead of using, for example, importing like a BERT Hugging Face library using LangChain framework for certain tasks that don't even require ChatGPT. So that's what I was just.
Yes, yeah, you can go in many directions. So right now, nothing came up. So when we plan the next session, right now, we don't have any questions that we need to investigate. So I just put it here.
Okay.
And during the week, well, I will add theory, I will add practice, and then there will be an announcement. That is what will be next week. So right now, I don't want to hold you for too long. I'm checking questions and answers and the chat. Okay. And I'm saying thank you very much to everybody. It's very exciting. And by the way, there is a rule. I learn more from my students than from my colleagues. I learn a lot because I'm every day, every week presenting this, so I'm forced to learn. That was my goal in the beginning, and that worked.
Oh, that's awesome. Thank you so much. Learned a lot.
Thank you, everybody, and thank you for those who came here the first time and come again, of course, and mostly ask the questions because that's the whole purpose. You can find lots of lectures on YouTube. Okay, everybody have a great week, and I see you next time.
Have a good one. Thank you. Bye.
Thank you very much. Thank you. Thank you, John.